All right, guys, I'm homesick today, so I expect you to be on your best behavior at school for Miss Worston. She is also amazing at math, so you can have her pause this video, slow it down, whatever you need. She can elaborate. I'm going to go through the whole thing, and I'm not sure what you'll have to use of it, if you'll need to use the whole thing, but it'll be here for you. I'm also going to try to upload this to Canvas for anyone absent and if you just want to study more. Okay, so let's get started. Be on your best behavior. Make sure you're taking notes. Make sure you are correcting any that you got wrong if you've already worked on it. And you should be writing down what I write down. So it says solve each of the problems below. These represent the types of questions on your test. Be sure to ask questions if you need more help with a topic. I can evaluate square roots of numbers less than 225. All right, evaluate the following. So we're just simply going to type them in our calculator. I constantly preach about how if you have your multiplication facts memorized, which means you pretty much have your perfect squares memorized, it makes math so much easier because you can do pretty much all three of these mental math. But since we're not all there and it's not all your fault, you are going to just type them in the calculator if you need to. So I just type in 2 times the square root of 49, which is 14. Got the negative of the square root of 100 is negative 10. And 10 plus the square root of 169, which is 23. I'm sorry, you're going to hear me cough and sniffle a lot, so I apologize for that. The square pool at Sammy's gym has an area of 144 square feet. What is the length of one side of the pool? Some of you are still not drawing pictures for these types of problems. Please draw your square. And you want to label the area inside, so A equals 144. Now, remember, some of these questions will ask you to find perimeter. This is just asking for the length of one side. Even if it asks for perimeter, you still have to find the length of one side. So we're going to label this S for side. If you are still dividing by 4, that is crazy because we have learned over and over again that you are going to find the square root of 144. You are not dividing it. That is not, 144 is not the perimeter. It is the area, so you have to find the square root. And so let's do that. So square root of 144. If you don't know it, you can type it in the calculator, but this is a perfect square. It is 12 feet. All right. Elena bought a square frame for her desk that has an area of 81 square inches. What is the perimeter of the frame? This one's really important because it is 2 steps. And it doesn't tell us what the first step really is. But I'm going to do what I know to do first. I'm going to draw a picture of the square. Okay, and I'm going to label it 81 inside because that's the area. Before I can find the perimeter, which is the measure around it, I need to first find out what the length of a side is. I do that by finding the square root of 81. Use Desmos if needed, but it is a perfect square. It is 9. So if one side length is 9, to find the perimeter, you could either add 9 plus 9 plus 9 plus 9, or just do 9 times 4. Actually, I'm going to do it this way. I like showing what the parentheses 9 times 4 equals 36. Please remember that even if you got these right, you need to be adding to your notes because some of you got a similar problem wrong on your assignment from last week because you didn't show any work. So yes, you can use Desmos, but I need to see what you are typing in your calculator. All right, between which two whole numbers does the square root of 150 lie? So the square root of 150 is not rational. It's a non-perfect square. You can just type it in, square root of 150. So that is between 12 and 13 because we got 12.247. That's going to be between 12 and 13. And so this is the answer. But here's how we can also know. We know that the nearest perfect squares, or I should say the square root of 150 is between the perfect squares of 144 and 169. But when it says whole numbers, they're talking about the square roots of each of these. So this is the answer. If you need any clarification throughout this video, please have Ms. Worston pause it, I think you should even be able to slow it down, whatever you want to do. I know I talk fast and I'm going faster because I'm sick and ready to go to bed. Which of the following is a true statement? Remember that these signs, the way it's facing, that means less than. So that means 7 is less than the square root of 65 is less than 8. So we need to find out, basically, are those in order from least to greatest. So I'm going to write least to greatest. So I'm going to compare 7 with the square root of 65. These problems look overwhelming, kind of, because you have to test out all of them until you find the answer, basically. But it's still, you have a calculator. Don't be lazy. So 7, I don't want to type that in. So square root of 65 is 8.06. So you got 7, then 8.06, and then 8. 8 is less than this. This is not right. Those are not in order from least to greatest. Okay, so now we've got 2 and 3. We have to figure out if the square root of 7 is in between there. 2.65 is what that would round to. So yes, so far that looks like my answer, but I know that the best test taking strategy is to check all of my answers, because if I had really kind of done something wrong or had some wrong thinking about that one, then if I find the right answer down below, I would know to go back and check that one. So I'm going to check all of them. We have the square root of 95 is definitely going to be less than 10 because the square root of 100 is 10. So that one's out. Okay, so now I've got square root of 160 for letter D. That is under 13, so that one can't be it either. So we were right on our first try. Number 6, a square sandbox has an area of 75 square feet. Estimate the length of one of the sides of the sandbox. All right, let's draw our square. Easy to draw, even for me, and it's a good visual. So the area is 75, and I'm finding one of the lengths. Okay, so here's S. Do not divide by 4. I repeat, do not divide by 4. Another way I've told you to remember this is you are in either 7th grade honors or 8th grade on level. It's the same course. At this age, at this level of math, you will never have a problem where you divide by 4 and that is your magical answer. Okay, it's just not going to happen. So square root of 75. Unless it tells you otherwise, go ahead and round to the nearest tenths place. So square root of 75. Since we're rounding to the nearest tenths place, I'm going to kind of iterate how to round, because some of you are still kind of getting that wrong, but you're doing better. I'm going to copy down. The tenths place goes to the 6th. And you want to also copy down the digit after, which is hundredths. I'm rounding the 6th, so I look to this one. Remember, 5 or more, raise the score. 4 or less, let it rest. So that becomes 8.7. It is a length, so it's not squared. It's just that. Oh, got a long way to go. All right, Shiloh estimated the square root of 190 by placing the point on the number line below. Explain how his estimate could be improved. Well, let's test it out. Square root of 190. This is 13 point. If I'm rounding the nearest tenths place, I put the tenths and hundredths. Use that to round. So it's 13.8. I know I'm going fast, so please pause it or slow it down if you need to. This number is more than halfway, right? And this one is not. So he could improve it by making it closer to 14. Okay, number 8. Which point below is the best estimate for square root of 5? We can kind of tell this by looking, if we know our perfect squares, especially the lower ones. Just FYI, square root of 5 falls in between the perfect squares of 4 and 9. Well, the number 5 is way closer to 4. So that gives us a hint. But type it in. 2.2, that is much closer to A, just above 2. So that would be good for the square root of 5. So it is A. The point below represents which of the following? All right, so we could say, just by looking at this, that's around 8.5-ish. All right, so let's see. Square root of 80. Nope. Wait, no, definitely not, because that's really, really, really close to 9. Square root of 72. Ooh, that rounds to 8.5. So let's put a check mark next to it. Square root of 67. Oh, whoops. Oh my gosh. Okay. Square root of 67. That is really close to 8. So it is going to be B. Number 10, the point below best represents which of the following? Well, we know that the square root of 144 is 12. So this one is kind of obvious. This is really super close to 144. So to keep up the pace a little bit, this one's obvious. It's letter A. It's not 146 because that would be above 12. All right. I can describe relationships between sets of real numbers. Fill in the first blank of each sentence with either rational or irrational. Then fill in the second blank with your justification. Okay, so the first lesson we had over classifying real numbers was over just that, rational versus irrational. Please remember that if it's a fraction, remember a fraction is a type of ratio. And notice, ratio is in the word rational. So if it can form a fraction at all, it is definitely rational. Irrational is always going to be either a non-perfect square or a decimal that goes on forever with no repeating pattern. Remember that repeating does not mean only continuous. It means continuous in a regular pattern that you can see. Oftentimes, well, actually all the time, it will have a bar over the top. The irrational ones will end in dot, dot, dot. But notice what I have on the calculator now. There's no dot, dot, dot there. And I've gone over this, but the calculator does not do that for you. If you notice that it's a bunch of numbers that are not in a pattern, that does mean that it goes on forever with this calculator, just FYI. Okay, so 0.87. It is definitely rational because it terminates. It ends. The negative square root of 121, that would be negative 11. You can use a calculator if needed. That is rational. It will be really funky looking if it is irrational. So most numbers you see are pretty much rational. So rational because it is a perfect square. We know more specifically it's an integer because it is the opposite of a whole number. 19/99. You should be able to take a glance at fractions and know immediately, hey, that's a ratio, so it is rational. I want to check this, make sure it's still recording me. Okay, so it's rational because it's a fraction, which is a ratio. So that is rational. I know I talk and write fast, so please slow it down if needed. All right, square root of 70. I already know what this is, but if you didn't know, go ahead and type it in. Do you see any repeating pattern? Is there any bar on top? No. Now, there's not a dot, 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 but again, the calculator does not do that. This is irrational. It's only irrational, again, if it looks kind of funky. I like to say that because, I mean, if you kind of catch on to that, then it's easy to tell the difference. This is irrational because it does not end, doesn't terminate. And it does not repeat. So it is continuous, but it doesn't repeat in a pattern, so it's irrational. All right, we got 0.72 with a bar over it. That means that is repeating. So we know that it is rational because it's a repeating decimal. I know this review is long, but please take advantage of this time. Jot on everything you can so you can study. Yes, we do retests here, but study so that you can make the grade you want to on your first try, and then you can be proud of yourself and you will avoid having to come into tutoring for a retest. The set of values below contain only irrational numbers, which could be the fourth value in the set. All right, so I'm guessing this is least to greatest. The negative of a square root of 82. Oops. There we go. I'm going to round to the nearest tenth for this. Negative 9.1. This one's done, well, yeah, and then we got 6.82. I'm going to go put dot, dot, dot. And then square root of 11 is 3. Oh. Okay. Never mind, this is not least to greatest. Sorry, mistake. We're just looking for an irrational number. I made a mistake on that. So 313, and we're just looking for an irrational number. I'm going to erase that. And I'm not going to start this recording over because I made it so far. Okay, we're looking for an irrational number. This one is a terminating decimal, so that's rational. 4/3, fraction, know that it's rational. Pi, we know that pi is the most famous irrational number of all times, and that multiplying it by 3 will not suddenly make it rational. So this is our likely answer. Letter D is a repeating decimal, so it's not that one because that would be rational. So it's letter C. All right, number 13. Cameron classified -18/3 as real, rational, integer, and whole number. Is he correct? Why or why not? All right, so remember that all the numbers that we talk about in class are real. So it's definitely real. Remember we talked about imaginary numbers. I've given you a couple of examples just for fun, but you don't need to know anything about that. All the ones we study are real. Is it rational? Why, yes, because it is a fraction. Is it an integer? Okay, well, -18/3 equals -6. Is that an integer? Yes. Now, is it a whole number? No. -6 is the opposite of a whole number, which is what makes it an integer, but it is not a whole number. So I would put, no, it is not a whole number. Everything else was true, though. Okay. Classify the following numbers to all of the number sets which they belong. Choose from, I'm going to highlight these. Real, irrational, rational, integer, whole, and natural. Okay, so they're all going to be real. In fact, I'm just going to go ahead and put real. That's all we study in here. Okay, -18.75. It terminates, so it is rational. It is not an integer. It is not a whole number, and it's definitely not natural. Square root of 36 equals 6. Where you know that it's real, it's not a negative sign, it's just equals 6. It is definitely rational. Any whole number integer is rational, because remember it falls in the little Venn diagram, and you can make any whole number or integer a fraction by throwing it over 1, because anything divided by 1 is itself. Okay, so is it an integer? Yes. It is whole. And remember, the only difference between whole and natural is that whole contains the number 0. Natural starts with 1. So yes, it's also natural. It's all of them. Okay, pi squared. Again, pi is irrational. And there is no smaller classification inside irrational. All right. The graphic organizer is used to organize sets of real numbers. List the section that each number would belong in. Some of you did really bad on your quiz because of problems like this. On tests and even the STAR, it is not going to be labeled for you. You are going to have to memorize, and most of you already have now that we did quiz corrections, but you have to be able to label it. And I would always, always, always label it before I answer any questions. So again, our first lesson, remember, they're all real. All of these are real. Our first lesson was over rational versus irrational. So A is rational. And then E is irrational. You cannot answer any of these questions if you don't know what those letters mean. A little more specific from rational is integer, then whole, and then we're going to put N for natural. 0. 0 is not natural because natural starts with 1. It is a whole number. So we're going to put C. Okay. Square root of 3 is irrational. You can type it in if you need to, but it's not a perfect square. Oopsie. There we go. See, it goes on forever, continuous with no pattern. So it is irrational. It would go under E. 8/5, I see a fraction. I automatically know it is rational. And if you divide 8 by 5, 5 does not go into 8 evenly, so it's not an integer or below. It's just rational, so it'd be A. -14/7. We already know it's rational because it's a fraction. If you divide it, it's -2. So it's definitely rational, but more specifically, it is an integer. So square root of 25 equals 5. So it is a natural number and everything else. So natural, whole, integer, rational, but the most specific it is D, natural. All right. Label the following statements as true or false. Every real number is a rational number. Okay, that's not true. It can be rational or irrational. Oh, I guess I'm supposed to label it true. Okay, so, no, I mean false. False. Every whole number is an integer. That is true because integers are whole numbers, all whole numbers, and their opposites. So this one is true. Some irrational numbers are integers. No, absolutely not. That's very obviously false. Some integers are natural numbers. Yes, that is true. Not all, but it says some. So like number 3, that's an integer, also natural. All right, getting close to the end, guys. Kind of. I can convert between standard and scientific notation. A marine biologist discovered a species with a diameter of 0.00085 inches. Express this measurement using scientific notation. Okay, I am going to rewrite it so I can do my work. There are 3 zeros, then 85. Remember that we already learned this. We need there to be, in scientific notation form, there should be 1 single digit, then a decimal, and then any remaining significant digits. That's just the form of it. And, okay, so we need our number. Oh, yeah, sorry. The first number needs to be between 1 and 10, but it's actually less than 10. So between 1 and anything less than 10. So we need our decimal here. We're going to move it 1, 2, 3, 4. So our first number is 8.5. We know for sure it's times 10. We had to put times 10. If we put the exponent on the 8.5 itself, then it is wrong. We moved it 4 times to the right, so it is negative 4th power. So we say that 8.5 times 10 to the negative 4th power, or 8.5 times 10 to the power of negative 4. Frankie entered a sweepstakes to win a grand prize of, oh goodness, I'm not going to say that. Let's think that's billions. So 10,500,000,000. Express this amount using scientific notation. Again, I'm going to rewrite it. Okay, we talk about invisible math a lot. Based on invisible math, the decimal in this is right here at the end. Remember, at the end of any whole number, however big or small, there is an invisible decimal at the end that you can add because it doesn't change the value. It's just invisible because we don't need it if there's nothing after the decimal. So now we need to move it to between 1 and 0. So moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my new number is 1.05 times 10 to the 10th power. It is a positive because it is a larger number, and we're moving to the left. All right. Which of the following is a correct representation of 0.000005? Okay, well, we know A is wrong because that's 2 significant digits. We have to have just one. The number has to be between 1 and 10. 1 and less than 10. So that one's automatically out. Then we can cross out letter D as well because we know that this number is not between 1 and 10. So now we're checking. We don't really have to do this problem. We can just kind of, we can really just kind of process elimination for this one. We also know it would be negative because it's a really small number. So it's going to be B. I like to make sure, I like to double and triple check myself. So I'm going to go ahead and do it. 1, 2, 3, 4, 5. Okay, yeah. So I need my decimal here because 5 is between 1 and 10. 1, 2, 3, 4, 5, 6. So 5 times 10 to the negative 6th power. Okay. Which of the following has a value that is greater than 10,000 but less than 100,000? All right, well, 9.86. Move it 3 times. We have to rewrite it. That's not my final answer. 9,860 is actually less than 10,000, so it does not fall in between there. Now I've got 1.6. I'm moving it 5 times. 1, 2, 3, 4, 5. I'm going to add 4 zeros. Now that's 160,000, which is greater than that, and it needs to be in between there. So that's not right either. Now I've got 5. My invisible decimal is here. I need to move it 3 times. 1, 2, 3. Adding 3 zeros. So that's 5,000. 5,000 is not between 10,000 and 100,000. I hope it's D. All right, 8.721. I'm going to move that 4 times. 1, 2, 3, 4. Put a 0. So 87,210. That is, in fact, in between those numbers. So it's letter D. Okay, Astrid is going to convert 0.0000678 into scientific notation. What exponent will 10 be raised to? Well, we need our decimal here. So 1, 2, 3, 4, 5, and it should be negative. So I'm going to put negative 5. Trey converted 12,500,000 into scientific notation as 12.5 times 10 to the 6th power. Is he correct? Why or why not? Well, let's go ahead and just do it. We're going to write 12,500,000. My invisible decimal is here. Oh, I didn't notice this. We can already tell by looking it's wrong because this number, first number is not between 1 and less than 10. So I need to also put he is not correct. All right, 23. Which of the following real numbers has the smallest value? Convert them all to decimals. This one's already done for us. 6 pi is, I'm around to the nearest tens, 18.8. 20 divided by 3, 6.6 repeating, and then square root of 51 is 7.14. So the lowest number, we can just compare whole numbers here. It's going to be 6.6, but I have to choose the original format, which is 20 over 3. Okay, 24. Which of the following real numbers has the greatest value? Here we go, 13.09. I'm going through these really fast. Please, again, feel free to slow it down or stop it at any point. 13 1/5. You can use the calculator, but it's 13.2. Remember the trick I taught you, though? To avoid changing this number into an improper fraction first, just put 13 point. And if you don't know what 1/5 is as a decimal, do 1 divided by 5. And that's where I get the 0.2. Square root of 169 is a perfect square. It's actually 13. I'm going to go ahead and just put 13.0. And then 13.1 repeating. Which one is the greatest? Well, they all have 13s. So I check the tens place. 0, 2, 0, 1. 13.2 is the biggest, so I circled 13 1/5. Okay, fill in the blank with the correct inequality symbol. 4 plus the square root of 15 is, we'll round the nearest hundredth just in case the other one's close. 7.87. Now 3 plus square root of 6. Oh, this is an obvious one, 5.45. This one is obviously bigger than this one, so our greater than sign is this way. Or we have to be able to read it left to right. All right, fill in the blank with the correct inequality symbol. The negative of the square root of 95 is negative 9.7. This is negative 9.2. Negatives work backwards, remember. So we were trying to figure out which one, if the square root of negative, oh my God, if the square root of negative, oh my gosh, I can't say this. The negative of the square root of 95 is less than or greater than negative 9.22 repeating. So I'm going to compare. Right now, the whole numbers are the same. Then I've got 7 and 2. This is actually lower than this one, the negative 9.7, because the negative 9.7 is further away from 0. It's further to the left than the negative 9.2, so that is less than. My nose is starting to pour, sorry. 2 more questions, guys. Place the following values in ascending order. That means least to greatest. I would make a little note of that. They're all negative, so it's going to look kind of backwards, but we're going to change them to decimals first. Negative 1.03. Negative 3 halves would be negative 1.5. Use the calculator for any of these that you need to. Negative 2 times the square root of 2 rounds to negative 2.8. And then Negative pi, we'll just negative 3.14. All right, ascending order. The lowest one, the one furthest away from 0, is 3.14. So we're going to put in original form negative pi. I'm going to go and cross this out. Okay, after that would be negative 2.8. So I'm going to put negative 2 times the square root of 2. And then we compared tenths places here. Next would be negative 3 halves. And finally, negative 1.03. Have we made it? It's the last one, guys. Place the following values in order from greatest to least. So greatest to least. Let's convert them. 91 divided by 10 is going to be 9.1. 3 times pi is 9.4-ish. Rounded anyway. Then I've got 4 times the square root of 5. 8.9. And then 5 times the square root of 4, which is 10. Greatest to least. My biggest one is 10. 5 times the square root of 4. Cross them out. My next to highest would be 3 pi. Then 91 over 10. And finally, 4 times the square root of 5. All right, guys, study hard. Try to come in on Tuesday, ready for your test, not needing a retest, or not thinking that you're going to need one. Study, and again, I will see you on Tuesday. I'm going to miss y'all today. Have a good one. Bye-bye.